So this is the new rear end housing that I'm putting in this year into the Asphalt Gundam. This is a stock car style rear end to go full floater, and why I'm deciding to go with this 9-inch over the more factory style one that I currently have in there is that these snouts on the end are cambered. It should give me 1 degree of negative camber in the rear versus 0, and that should work out quite well as far as on track in the corners and specifically power off of corner. So hopefully that'll work out. I got a generic kit that's for circle track stuff. It looks like we'll have to do a little bit of modification to make it work, but we'll see how it goes. These are the hubs that go on the outside. They're significantly larger than the stock style. They also use a big bearing by comparison. I believe the bearing that goes in here is larger than even the full outside of the housing bearing on the 4.9-inch from the factory. And then it's a floater setup, so what that's going to do is it's going to lock this hub in place. It won't be shifting back and forth with whatever play is in the axle. Not as much of a problem on the factory 4.9-inch stuff, but it definitely was on the stock 7.5 that came in this car, because that axle was a C-clip axle, so it floated around based on where the little bit of slop in the C-clip in the middle. The other thing is it has this integrated heavy-duty brake rotor mount, which this will be a good strength and safety upgrade in the rear compared to what I have now, which is just like a slip over stamp steel hat kind of a deal. These are kind of heavy, but actually there's a lot of extra material out here. I mean, this is a lightweight version to start with, where it's all windowed out like this, but there's a lot of material out on this edge that I don't need. I've already measured, and I can it's like 7 inches right now, and I can cut it down to 6 3/8 on the outside, and that'll still be slightly wider seated flange than what I have now, but my wheels just aren't any bigger than that on the back, so all of this extra material being on there is really going to do nothing. In the way it's, you know, they're relieved here anyway. We won't even be going all the way up to this radius. It'll probably be just outside of that somewhere, so I don't know how much weight we'll take off with that. Maybe a pound a piece at the most, I would guess. I'm not really sure what that is. I mean, it's quite a bit of steel that'll come off of there, but we'll see. These are the lightweight drive hubs for the axle, so it's splined on the outside. These have to bolt onto there because the axle will stick out and then engage to these splines. However, with this step here, this is much larger than what I have in my wheels. This is 3-inch 50, and 2.770 is what the factory sized for the front, the Cutlass, and I want to have that matched on the back like I currently do. I had to cut down the 4.9-inch ones anyway on the stock style axles. The hard part here is it's got this relief on the backside, and I don't think it'll cut down far enough without basically making this, fall apart. So I may have to find a different one that'll work. I could just fill this area with weld back here, and then it'll be plenty strong for me to machine down the front to make the right locator ring size. The rest of this sticking out isn't going to be a problem. Or I could just use this as a template and machine my own setup for it, although cutting the splines would be a hard part, so I'd have to just machine the outside and then have something where I could weld it. At that point, it kind of makes it more sense just to weld in here. I'll probably have to grind all this zinc coating off stuff. We don't want to be making any noxious gases. Shit's bad for you. The other thing is these are threaded studs. They're 1/2-inch fine thread that go through there. Current wheel stud is a 12 by 175. Yeah, I think it's 12 by 175. I don't know, these are just like a grade 8 kind of bolt. They go in there, they're probably fine. I think I'd rather convert this to like an ARP style wheel stud, or at least get a different, you know, something that's like an ARP bolt. But worst case scenario, I mean, I can still use these. I'll have to get different lug nuts for the thread to match, and I'll just have a different lug nut thread front to rear. These are the bearings that go in here, front and back, and yeah, these things are massive. So that'll be a huge strength and safety upgrade as well. And then the threads on the end of the snout there, got a lock ring and this aluminum nut for setting tension. This thing's 2 3/8, so I'll have to order a socket that'll fit that, or a wrench or something. But yeah, this should work out quite nicely. I was hoping it'd be a little bit more bolt-on than this, but honestly, it's not a bad price. I think it was, $1,600 or something shipped for all of this, so it's pretty good. Also, the axles I have are gun drilled, so that should save 2 or 3 pounds an axle, I believe, as well. But I do need to get all this stuff kind of mocked up so that I can swap things out. You can see I ordered this rear end with G-body mounts, or metric chassis mounts on it. This may make it easy as far as mocking it up after I get everything assembled, because given that I'm doing the cambered snout on the end, I looked at how much gap I had from the tire to the fender, as well as how much gap I would then be gaining by tipping the top of the wheel in and get farther away from the fender. So I was able to go with a wider flange to flange setup, which will move it out, and basically that would make it absolutely flush with the fenders based on the calculation, or the amount of room I was measuring before I ordered this. And then with the 1 degree tip in, it should gain back to like 3/8 inch of a gap up on the upper part of the tire that'll be tucking into the fender under compression. So we're looking to add some performance, but like I said, we got the mounts so I can mock it up in the car with the suspension setup I got. I do want to change the rear suspension. I really haven't decided if I'm going to try to do like a long arm triangulated 4-link for the sake of it. I don't think anybody's ever really tried it. I know they're putting longer arms, top and bottom, would help with weight transfer, and then power off corner, getting being able to plant the rear tires a little bit better. I know there's a few other guys that have done like a 3-link setup, and I bought parts to be able to do a 3-link with a Watts link for side-to-side control. So I've got that stuff here as my original option that I was going to go with, but I don't know. I really haven't decided which way I'm going to go. I know the 3-link will work. I know how to tune on the 4-link right now, so if it's just a matter of changing the weight transfer and retuning for that a little bit next year, we'll kind of see what happens. Now that I've been laying under the car and stuff, I'm kind of leaning back towards the 3-link, but that running the Watts link setup, which I would rather do over a panhard bar just because it keeps the rear end absolutely centered and doesn't go through an arc, is going to be a little more work because the coilovers are going to have to get repositioned a little bit. I'll have to make extra brackets off of the frame and stuff, because I'll have to have brackets on both sides, and I'll have to make the windmill or prop, if you want to call it that, that'll have to be mounted to the back of the housing. And it's just kind of like you got fuel lines from the tank, and there's some other stuff going on there. There's room. It'll just take some reorganizing of what's going on there. Alright, already found another thing I'll have to address. If this will focus. I don't know, maybe if I just bring it closer. There, you can kind of see it on that bolt in the back. See that gap before the head is seated down? That's where it's binding out. Right here, and it's doing it on every single one of them bolts, so they didn't get chamfered enough on the threads to be able to get these bolts to sit down on the way. That would for sure be a failure if it stayed that way, so I'll have to look into changing something there to make it better. Alright, I finalized my plan for these hubs. I went and weighed them. They're currently 9.6 pounds each. I don't know what exactly I'll gain. I'm hopefully maybe take a pound off them by cutting down the OD. I did find that the ARP studs that I have been running are for a 1/2-inch press and hole. These are 1/2-inch threaded holes. So that works out great for me because instead of using them bolts that don't work anyway, as you saw in the previous clip there, I'd either have to run a washer on those, which really seems dumb, although they are spot-faced larger, like they do take a washer, but no washer hardware was sent with them, and that just seems like a dumb thing to do. So what I'll actually do is I can snag a reamer and borrow that from work tomorrow, and then I can take these out, set them up on the lathe, cut down the OD, and then I can set them up on the mill, and then I'll just ream the threads out of the holes. I'll have a nice clean hole that'll actually, then the splined area of the ARP stud will bite into, and I can press those in, and then I can keep using the studs and lug nuts that I have without having to spend another $200 to replace that stuff. So I don't need to go tightening this thing down or anything beyond hand tight. get the slop out of it. It spins real nice. Ooh. Make sure there ain't no wobbling or something weird going on, like maybe I got something on there crooked. Looks like it's spinning nice and true, so. Now you mock up our brake rotor. So I always want to use new pads for this, that way they're even side to side. You don't want to use used pads because if they're tapered or something goofy, you're going to have your alignment off on getting the rotor both centered and square. Or not the rotor, but the caliper. Alright, because I tend to save these things when I make them, this is actually the CAD, cardboard aided design, that I use to make the brackets that are currently on the car. The reason I had to remake brackets that were on the car was the like bolt-on dirt track style, or not bolt-on, I guess weld-on style that I had modified. Was like 3/16 thick, and I ended up shearing and cracking through those. So this material is 5/16 thick, and that's what I've been running most of this year now. This should be plenty thick enough for the rears. I mean, it's over a quarter-inch thicker than what I've been running previously that cracked. So, and it just so happens that because it's a 4/9, so it's in there, it's the same axle tube diameter, so the spacing's going to end up. The brake rotor is the same size, it's the same calipers. So I can take this cardboard cutout and I can scribe a line around the outside, and then we can cut it out, shape it a little bit. I might center punch just one of these holes to get started so I can drill and tap it to hang the caliper from it, and then we have one spot that's actually held in place, and then we can transfer punch the other one. Then finish drilling and tap both of these, bolt them up to the caliper, and then weld on to the rear end. Because I know this is going to end up about on top of that weld for the snout end, I know I'm not going to be able to make this perfect for like a 3-inch cutout because I'm doing all this by hand. I mean, I could take this template, draw it up in actual CAD software, and then get it burned out or cut. But you know, that's involves more time, and really this isn't critical enough where I need to bother with that, because I can just cut these out and I can probably have both of them made in an hour or two and ready to weld onto the rear end. Now I could put bluing down and dye just to see where the lines are a little easier, but with this darker scaling, it's actually not that big of a deal. I can actually see the lines fairly well. Just take my scribe, trace the outside, try not to let the cardboard peel up anywhere, and make my line off. You can see that. So I can line it back up. Maybe we'll put one center punch in it for a starter. So that can be the starter hole that we use to drill and tap, and then we can hang the caliper from there and then center punch the other one when we get it on the rear end and set up. The reason I'm not doing both of them center punch at the same time is I know that this is just cardboard, it's not perfect, and I want a nice, tight, snug fit to the bolts to the caliper so that they stabilize it. I even have bolts set up where they got a little bit of a shank, so there's a smooth area to contact to reduce stress during the braking forces. So to make sure that it's going to be that accurate, even though we're doing this in a non-accurate way, is going to be, I can have one to start. We're going to have a little bit of a gap down here on the axle anyway, just so that we can fill that with weld and have it be a good 100% penetration weld. and then we'll transfer punch the other one so that we know it's an exact lineup with the caliper where we need it to be. Alright, now I got my part roughed in. Got a couple of notch marks from making the last set out of that piece that I didn't see on the back side, but that's fine. We can hit that with the welder and then grind it down flush and blend it out. It's all the way right at the edge anyway. Oh, we're got a pretty good lineup there. Might be a little small or big in places, but it's good enough. Plenty good. This is just a piece of 3-inch exhaust tube that I was using for checking the fit. Again, it doesn't have to be dead perfect. I mean, we're going to be grinding back a whole bunch of this just to fill weld in there anyway. The large part of just getting this fit to 3-inch right away is to make sure that when we can set it down on the rear end and then check our fitment with the holes that it will be spot on. So I got the one hole center punched. I'll go over, set on the rear end, kind of mock everything up, make sure that that hole looks good through the hole on the caliper. And then close, because if it's off, we'll have to just kind of ignore it and try again and maybe just center punch it from over there. We'll have to figure out a way to clamp everything together. But just go check that quick. So here's what I did for checking that center punch alignment. I just have these magnets holding the bracket tight down here to the tube and holding it square, which it won't be perfectly square because we do have our 1 degree of camber built into there. So I set the caliper on top, and then the center punch is right here, so I just rotated the caliper around until I could see the center punch, and then I lifted it up to line up the top of the pads and the rotor like we talked about before, and then I was able to just look through here and see that my center punch looked pretty dang close. Like, close enough where it's like, yep, that's near the center, not where it was significantly off to one side or the other. So then I know now that I can drill and tap the bracket for that one, we can put a bolt in it, and then we can line everything up and center punch the second one. Now this would be a time where if you have a drill press or a mill handy, that it'd be a great time to use it, so you can make sure that these holes are drilled perfectly perpendicular to the material. Same thing with getting the tap at least started. I do not have that luxury here at the moment, and I'm just going to have to do my best to keep the drill square. I'm going to start with a small drill to get a pilot hole in there, because that'll help when you go up to the trap drill size, that it will cut faster, so you're more likely to keep it straight versus having it kind of wander around as you spend more time trying to drill through the material blind. Now I'm going to be tapping it for 7/16, 14. So that's is it one size up or one size down? There's 23/64, so it's one size under 3/8. If you don't have a 23/64, so 3/8 will be used just fine. Should note that when I've used bracing like this, I'm putting some down pressure on, but I'm trying to let the drill do the work. More or less, I'm pulling it in tight here so I can make a lot more stability to keep that drill straight while I'm drilling. So now we've got our hole, we'll get our deburr tool. Just run this quick around both sides, helps knocks the edge off. Then we can get our tap ready to go. This is probably the most important thing to keep straight. It's a tapping cycle. Especially as you start. Obviously there is a little bit of wiggle room in threads, and when you run it down tight it's going to want to square up against the bracket, but we want to have it as good as we can. This is why using a drill press or a mill is a good move here. Now if you need to, you can always check this with a square. Or in the case of the handle here, a square doesn't always make it nice, but I can always use the end of a ruler too. I can push that out. That looks really good. It's touching all the threads. Go it the other way. Pretty darn close. It needs to go that way just a hair. So I'm just going to put a little bit of tension on it that way. Keep turning. There, now we definitely got a thread started, so I want to double check again. Oh, it looks good. Well, that's good. Oh. Turn it to start the cut, and then you can back it off just a little bit. That lets a little more fluid get in there for lubrication to help your next cut. Now, if you back it off far enough, you'll break the cut debris or whatever, the chip off of there. But you don't have to go all the way that far. I mean, just backing it off a little bit to get a little lubrication back on the leading edge is usually enough that you can make a nice clean cut. And then as it breaks through, and get those chips out of the way. We got a nice clean hole because of how easy that turns. And grab our bolt just to verify. Yep, that's nice. Take our deburr tool again because we're going to have another little bit of an edge on here. I want to get rid of that. Anything that can be a potential stress riser, and sharp edges do that, especially on a bolt hole. You can actually rip the threads out. Not usually on steel like this, but the cast iron it can be a problem. Oh, you can just check it with our bolt again because sometimes it folds over a little bit of debris. And then see it stiffens up a little bit, but we can get a wrench and run this through and then it'll it'll just fold over that little bit of material that got pushed over during the deburr process. And that's all it took. So now it spins nice and free. Take that out, wipe off any little grit that got in there. We can always blow this out with the air to make sure. And then now we're ready to go over, use magnets to line this up, bolt it up tight to the caliper. The caliper will pull it flush where it needs to be. We'll need to check to make sure that this upper edge isn't getting a corner into that flat cut on the caliper, or we'll have to cut this edge down a little bit. And then we can bolt it up. It'll pull it all nice and square. We can then hold the other side of the caliper up in position, put a transfer punch in there, give it a tap. We'll then have a hole location. We can drill and tap that one. And then we'll be able to go back, bolt it up tight, and then look at marking out where we got to go for welding this on. So I had to grind this weld that sticks up a bit off of this backside where I plan to put the caliper bracket, because otherwise the weld was holding it up too high and it was actually causing it to tip the caliper one way or the other. I think it was tipped up to the outside of the rotor where one pad was riding higher than the other. So we ground that off. I'll get the hub and everything put back on, and then we'll get to transfer punching the second hole. This is where having that socket that fits this would be nice. It's ordered. Won't have it till next week though. So I don't need to hold it all up there to make it transfer punch. Actually, the way that the bracket worked out, it's sitting tight against that flat cut on the back of the caliper for the bracket. So you can just transfer punch it the way it sits right here. Just gotta get that in and just give it a whack. Yep, we got a point. And now I take that bracket off and redo it. I was lifting it up to get it positioned up and down relative to the rotor where I wanted it. It looks like we're going to be pulled off about a 1/16th to maybe an 1/18th of an inch, or to a 1/8 of an inch at the most, which should be great for being able to get a good full penetration weld down in there. We'll just chamfer the edges a little bit more so we can put a nice fat bead on both sides. But for now, I just want to get so we can bolt up both sides of the caliper. That'll hold it in place, and then we'll need to get it back on there, figure out a way to make sure we can clamp everything tight with it positioned in and out where we want it, and then we just gotta line it up, put some tack welds on it, and then we take everything off out of the way and finish welding it. Now with both bolt holes drilled, tapped, everything's pulled up nice and flush. I know I have clearance to the flat cut here in the back where I'm not going to be having it twisted or cockeyed or anything like that. This would pretty much be ready to mock up and then be ready to tack on. But otherwise, I'm getting ready to weld these brackets on. As you see, I've been fitting them. I actually have the scribe lines about where it needs to go, so I'm a little shy of that, and then I'm like assembling it with the caliper and the pads and everything, and then working my way down to the tube to get the height right. And then this one I've already managed to make that happen, and then I've V'd it out on both sides so we can get a nice full penetration weld on both sides. To set up the caliper and get it centered, I ended up measuring what the distance across was, and then subtracted the rotor and then the pad heights, and it came up with 75 thousandths, and I just happened to have this material laying around that is between 70 and 75 thousandths. So it actually comes out where, I mean, with a little bit of a wrinkle bend in them, I had to push pretty hard to get this to slip on here. But then the nice thing is it's held in place now on the rotor, so I'm not trying to balance 20 different things and having it flop side to side. The biggest thing here is, since I got these sheet metal pieces stuck in behind the pad, it's going to hold the caliper nice and square to the rotor, so that we can make sure that when we weld the bracket on, that we're going to be getting the bracket square to the rotor, so that we don't have any weird offset anything going on as far as the rotor spinning and then the pads wearing funny. Now I'm just mocking this up to get ready to weld it. I kept grinding on that bracket until I got the top of the pads just below the top of the rotor right here. They're actually pretty much flush with the end of that chamfer. And then, to see about my position in the arc, I have a block underneath where the center section goes in the housing over there, and then I took my level gauge and I flipped it onto the mount surface for that. I zeroed it out and I flipped it around and I've set it on top of the caliper here. As you can see, it's showing that it's 0.06 of a degree off where it's sitting. That's plenty good enough. So we're definitely getting it close. The nice thing about the setup, I can already tell this is going to be way better than the brackets I've done before. And I think a lot of that has to do with putting these shims in and forcing it to sit tight all the way across here. Because before I had just been like eyeballing this gap on each side. And one thing I noticed was I must have got the brackets on crooked, because one side would end up slightly higher or slightly lower than the other. So I think this is a way better solution where it's pinching everything tight, and then I'll be able to come in, tack weld the bracket down to the tube there, get a couple of good tacks on it, and then disassemble everything and finish weld. Alright, I've got everything in place. Got my caliper where I want it. I got it leveled up. The nice part is we have room to the lower mount. I didn't have the room to put the caliper vertical before. That has to do with the wider wheelbase. Now I got the TIG welder set up because I don't want to mess up that bearing that's inside of there. So we'll just work on getting this tacked in place and go from there. I also wipe this down with acetone ahead of time to make sure that everything was nice and clean. And I just want to get a couple of tacks on this side, and then I'll take all this off. I can get a few tacks on the other side, and we'll try to minimize the amount of movement that flange might go through based on heat warpage. Not too bad. So what I did was I did 4 small tacks, and then I did 3 heavier tacks on the back side, and then I did this full weld on the front side. Hopefully that kept the warping to a minimum. And everything should line up still pretty nice.